In this video I'm going to show you how you can draw a box plot from a cumulative frequency graph, and then I'm going to explore how this appears in exam style questions. Here I've got a cumulative frequency graph, and it's for the length of some pipes in a hardware store, and I'm given the information that there are 250 pipes, but if you're not sure, the first thing I would recommend that you do with a cumulative frequency graph is read off from the very top value and show that the total number of pipes in this hardware store is 250. Now, in order to draw a box plot, you need 5 pieces of information. We're going to start with the first thing that you should do in order to get onto your box plot, and also a common question in its own right: how do you work out where the median is from a cumulative frequency graph? Well, if you have a total number of items, 250, the median is going to be halfway through those items. Imagine that all these pipes are lined up in length order, like this, 250 of them. You want to get to the middle. Now, with small numbers you have to do a little bit of maths, and it's a bit trickier to find the halfway point, simply because if you've got 7 items, for example, it's actually the 4th item that is the middle number, not the 3.5. But when you've got large numbers like this, like 250, it's entirely acceptable, because we are only estimating the median in this case anyway. It's entirely acceptable just to do half the number. So I'm going to do halfway to 250 is 125, which is in here. Okay, 125, and that's halfway to the total, and that will find me my median. So let's put a line across and down, and this tells me that my median is at around about, what's that, 96, 97. That's the first piece of data that I need, that median, that number right there, 96, 97. The next pieces of data that you need are the quartiles. Now, quartiles are a bit like the median. The median is halfway through your data. Well, the lower quartile is a quarter of the way through your data. So you need to do a quarter of the total. 1/4 of 250 is 62.5, which is just there. And that number is a quarter of the way to the total. It's a quarter of the way through your data. So you're going to draw a line across from that point, that position, and down, and this number here is your lower quartile. It's about 70. For the upper quartile, which is 3/4 of the way through your data, you need to do 3/4 of the way to 250. A quick way to do that is to add up these two numbers to get 187.5. 90, 85, that's there. And again, along to the red line, the cumulative frequency graph, and then downwards, and you can read off the upper quartile, in this case is about 130. So remember, the 3 lines that I've just drawn are a quarter, a half, and 3/4 of the total. You read along and downwards, and you find these 3 points here. In order to draw your box plot, what you're going to need is 5 pieces of data. So those 3 pieces of data will form the box part of your box plot. Now I'm having to transfer this down to here like this. You should use a ruler for this, but for speed I'm just doing it freehand. So I've got my median, which I said was at about 97. I've got my upper quartile, which is plotted at 130, and I've got my lower quartile, which is plotted at 70. That's 3 pieces of data. I said we needed 5, and the other 2 pieces of data are the maximum length of a pipe in this hardware store and the minimum length of a pipe in this hardware store. Well, the maximum length, in this case, you don't know what data this has come from, you don't know what groupings were used for this data, but my curve goes all the way up and it's still increasing up to this point, 200, so I'm going to use that as my maximum value. I haven't specified any units, by the way, but these numbers are meant to be in centimetres. I also need the 5th piece of data, which is the minimum length of a pipe. Now, rather unrealistically, this graph goes all the way down to 0, signifying that there are some graphs, some pipes of 0 length, but that's very unrealistic, so not likely to happen in a real situation. But since I don't have any other information to go on, I'm using that's my minimum and that's my maximum. So in summary, you need to do 5 things. You need to find the median, which is halfway to your total. You need to find the quartiles, a quarter of the way and 3/4 of the way to your total, and you need to find the minimum and the maximum, and then you can plot a box plot. It's quite usual to draw a box plot directly underneath on the same scale, but sometimes you'll be given a separate sort of grid to draw it on. Just pay attention to the scale. Okay, it might be, something like this, and you might just have to pay very careful attention to the scale and make sure that you get the box plot in the right place on your grid. So it might end up looking something like this. Just have to make sure you're paying attention to the scale that they give you. Okay, and not necessarily just draw it directly underneath. Let's have a look at an example from an exam question. This exam question says, Harry grows tomatoes. He put his tomatoes into 2 groups, group A and B, and he gave fertilizer to group A but not to group B. And we want to compare these 2 ultimately. But the first task that we have to do is we have to draw a box plot for this data. Okay, so you can see we've got the cumulative frequency graph, and then separately we have the box plot to be drawn here. Well, we go through the same data, the same process, of finding the total. Let's look at where the graph stops. At 60, so the total is 60. And actually we're told that in the question there. To find the median, we're going to go halfway to the total. Half of 60 is 30. So we're going to go across and down. And that gives us a median value of 170 grams of tomato. Okay, so the median tomato weighed 170 grams. I'm going to go ahead and put that straight away onto here. The median at 170 grams. Next up, I want to do the upper quartile and the lower quartile. Well, a quarter of 60 is 15. 15 on my graph is just there, 165. So remember, that's a quarter of the total. The total was 60, a quarter of the total will be 15. And I've read across and down, and I found 165 as my lower quartile. Let's put that on the graph, on the box plot. Just there, 165. Now I need to find my upper quartile, which will be found at 3/4 of the total. Along to the graph and downwards, and that gives me 170. 1, 2, 3, 4, 5. By the looks of things, 175. So I've just transferred that onto my box plot here, and now I've got my 3 lines that make up the box. If I join those up like this, that's the box in the centre of my box plot. And now I need to do the whiskers. Now this is something that they sometimes do on exam questions, and it makes a bit of sense. They tell you the minimum weight and the maximum weight separately. So you do need to read the information. The minimum weight was 153, so I'm going to go to 153 on my scale here and draw a 4th line, and then I'm going to go to 186 for my maximum weight. If you read here, maximum weight is 186 grams. Put that 5th line on, and then what you need is a single line from the minimum to the box, and then a single line from the box to the maximum. And that box plot is now drawn. A very common follow-up question is, can you then compare that with another set of data? Let me just sort out this paper quickly. There we go. I hope you can see those two. So we have the tomatoes from group A, which used a fertiliser, and the tomatoes from group B, which didn't use a fertiliser, and we are asked to compare the distribution of the weights of the tomatoes. So let's have a look at what we notice. Well, you can notice a few things. First of all, we could work out the median, or we could just look and see the medians are different. The median is a type of average, and therefore we can say on average group A tomatoes were heavier than the group B tomatoes. It's good to give a number for that, so we could say on average group A tomatoes were, what's that, 170, and that's 162, so the group A tomatoes were on average 8 grams heavier. Let's write that down in our comparison. So on average, group A tomatoes were 8 grams heavier. That's a good starting sentence for my comparison, but I also want to give a measure of spread. This is what mathematicians call the interquartile range, or the range. They're measures of spread because they tell you how spread out or how varied the data is. So let's have a go at calculating the interquartile range for each of these box plots. This is something which is a good thing to calculate because The interquartile range tells you how spread out data is, but it ignores the sort of outlying values at the top end and at the bottom end of your box plot. It really focuses on the middle 50% of the data, and in the case of these tomatoes, we're talking about the middle 50% of the tomatoes. So not the really big tomatoes, which might be really big for some other reason, or the really small tomatoes, which maybe have been in a dark corner and haven't managed to get enough light, but we're talking about the middle 50%. And the interquartile range is just the upper quartile subtract the lower quartile. So it's really this gap here. And in this case, in group A, that's going from 165 to 175, so the interquartile range is 10. If you look at this box plot here, you can see that this one goes from 158 to 166. So to work out the interquartile range for this one, you do the upper quartile, take away the lower quartile, which gives you 8. The interquartile range, therefore, is bigger in group A, and what that means is that the middle 50% of the tomatoes in group A were more spread out, more varied in weight. You could also comment, in the other way round, that the tomatoes in group B were more consistent. Their weights were more consistent. They sort of had a narrower band within which they fell. So you're talking about how varied, how spread out the weights of these tomatoes are. So let's write a sentence to describe that. Remember, group A are more spread out. Their weights are more varied because the interquartile range is a larger number. So we already have our first sentence. On average, group A tomatoes were 8 grams heavier. We can also say that group A tomatoes had a higher interquartile range, meaning that their weights varied more. And that would be a good comparison between the two sets of tomatoes. You've given an average and said what that means. It means that group A tomatoes are heavier, and you've given an interquartile range and you've interpreted what that means, which is it means that their weights varied more.